Today we're going to work through lesson 3, which is called the division of polynomials. First of all, after doing these for a few days now, we're starting to realize that the opening exercises are sort of like the warm-ups or something like a review of what we've done the past few days. So why don't you guys go ahead and try this one on your own and then check the answer. So you've got your classwork in front of you. I'm going to push pause and work out this problem, and then you can go ahead and check the answer with your answer. All right, there you go. Go ahead and push pause and check the answer. Make sure I didn't make any mistakes. Okay, open exercise continued. So this is again just like the warm-up. But this one I'm going to talk through a little bit. I'm going to write down the answer to the previous slide. Still in red. And the problem was actually 2x plus 5 times x squared plus 5x plus 1. If you look, how would you use the expression in part A to quickly multiply 25 and 51? If you're really, really quick, you'll realize that if I replace x with 10 for this whole problem, I get 2 times 10 is 20, plus 5, 25, times 10 squared, plus 5 times 10, plus 1. So I have 100 plus 50 plus 1, which is 151. So how would I use the expression in part A to quickly multiply 25 times 151? That pause is on purpose. I would replace all of these x's with 10. 2 times 10 cubed, and 10 is very easy to cube, plus 15 times 10, plus 7 times 10, plus 5. That gives me 2,000, plus 150, plus 70, plus 5, which does work out to 3,775. I'm not sure that's easier, but it's different and fun. All right, now we can get into a little bit of the lesson. So, our discussion, it's a one-sided discussion where you're going to sort of follow along and think to yourself, how can a multiplication problem be rewritten as a division problem? So if we look, multiplication is sort of like, we could say factor times factor equals product. That's our multiplication problem. If we wanted to make that into a division problem, we would, divide one by one factor, and we'd be given the other factor, etc. But let's do this. I'm going to erase this, and I'm going to write a few different ways to write division as a little bit of review from like elementary math. Let's just use the problem we just had, like 25 times 151. That's illegible. Oh, ha! That's not an eraser. Aw. Hold on. Let's try that again. I'm going to use the sort of fun problem we did. And to rewrite that as division, I would just do 3775 over, let's pick 25 equals 151. We all know how to do that though. But let's do the opening exercise. The opening exercise was 2x plus 5 times x squared plus 5x plus 1 equals x cubed, 2x cubed, plus 15x squared plus 27x plus 5. To rewrite that as a division problem, I would take 2x cubed plus 15x squared plus 27x plus 5 divided by 2x plus 5. And that's going to equal x squared. I did not leave enough room. 5x plus 1. So I just rewrote my exercise as a division problem. Now let's x equal 10. Let x equal 10. So everywhere I see x, I'm going to put 10. So that'd be 2,000 plus 150 plus, actually that's 1,500. Let's erase that. Oh my goodness, I did it again. Okay, sorry about that. So we'd have 2,000 plus 1,500 plus 270 plus 5 divided by 20 plus 5. This gives me 3775 divided by 25, which should in fact equal, if we replaced them up here now, 100 plus 50 plus 1, which should be 151. Okay, I'm going to grab my handy dandy little calculator and double check that. You can feel free to do the same. 3775 divided by 25, 151. Woohoo! All right, let's do an exploratory challenge. Does this first equation, let's highlight it, does this equal that? Justify your answer. I believe we just did. Let's go ahead and do some painful math. And we're actually going to set up a table. Okay, this might take a few minutes, so be patient and follow along. Okay, we're trying to get to this part, right? And that part is going to actually end up at the top, but we're not going to do that right now. Okay, let's fill in everything else. If we remember, when we first learned how to do tables, we would have factor and factor equals product. Okay, now at this point, I'm going to use this highlighter this time. Hold on, let me get the right color. Sorry. We know this part. We know this part. We're actually looking for this part. Okay? That was really messy, but you get my point. We're looking for the top factor. So, I'm going to have, oh my goodness, undo. We're going to have these boxes. I know this is going to be 2x and 5. I know that this is going to be 2x cubed. I'm not going to draw all the way through. This will be 15x squared. This will be 27x. And this will be just plain old 5. Okay, now you're going to have to follow the pattern how to do this. I'm going to do it in an order that makes best sense to me. First of all, I'm going to fill in this spot because it's the easiest. The only thing that equals 5 is what's here, so it has to be 5. Okay, and if you remember when we first multiplied, the top of this times the 5 equals 5. So what times 5 equals 5? 1. Okay? Now, next, we're going to come up here. Okay? We know that 1 times 2x equals 2x. Pretty simple. See the pattern though? Okay, next, we know that 27 is our answer. It's the sum of this block and this block. So what plus 2x equals 27? 25x. 2x plus 25x equals 27. Okay, now let's work this way. So 5 times what equals 25x? Double check your work. Oop, that's wrong. Sorry about that. 5x times 5 equals 25x. Okay, now let's go over here. We know that's 5x times 2x equals 10x squared. 10x squared plus what equals 15x squared? 5x squared. Okay, 5 times what equals 5x squared? It's going to have to be just plain old x squared. Double check your work. X squared times 5 is 5x squared. And this last one, 2x cubed. Okay, this goes here because there's nothing to add it to. So we just found our other product, which is right here. That is our answer. Awesome. We're going to do that a few more times. Describe the process you use to determine your answer to exercise 1. Okay, the process is really the reverse multiplication. Okay, we could write down every step we did on the last slide, which might take a little bit of time, but we're reversing the multiplication. Okay, we're doing everything backwards. If you look at the tabular method, we know this product, we know this factor, we know the quotient, we're trying to find this factor. Okay, so we're doing subtraction and a lot of multiplication. After we practice a few more, it'll make a lot better sense to you. Reverse the tabular method of multiplication to find the quotient of this one. Okay. Looks like we have x and -2. And this one, 2x squared. Here we're going to have x. I thought I did that wrong. Let me erase that and start over. I have too many squares. You felt me hesitating there for a minute, and that was why I thought I had too many squares. Awesome. So this first square is going to be 2x squared, x, and -10. This side will be x and -2. Now the first thing we're going to do is fill in this first square, which is going to be -10. So what times -2 is -10? Or you can just divide here. -10 divided by -2 is going to be a +5. And then we can multiply 5 times x. Okay, and then 5x minus x. But if we were to add these together, yep. So if we're adding these together, 5x plus a -4x equals x. And here's going to be just plain old 2x squared. So what times x gives me 2x squared? 2x. So right here is my answer. See, I just worked backwards. Here I had an x minus 2, which is just 2 rows. and x squared, x, and negative 10. So I needed an x squared. So if I have x minus 2, 2x plus 5, x times x, so to the first power and a constant, gives me a 2 by 2. Okay. Create your own table and use reverse tabular method to find the quotient. A conjecture I want to talk about really quick is, yikes, how many rows and columns we need on our reverse tabular method. Okay, if you look at this problem, it's x to the fourth is where we're going. If you look at the previous problem, you have it on the sheet there in front of you. We have our quotient, which is equal to our dividend over our divisor. If I look at the problem we just previously did, our dividend was the highest power of x squared. Our divisor was the highest power of x. Let me get to that problem again. Like I said, you have this in the sheet in front of you because you just did it. There we go. Yep. We're trying to find our quotient. So if we set up, that's when we set up our tabular method to be a 2 by 2. So our quotient is what we're looking for. Our dividend goes on the outside, and our divisor was over here. So when we had an x2, x to the second power, we did a 2 by 2. The problem previous to that, our dividend was cubed. Let's see, what was our divisor then? I think that was a singular one too. Yep. That gave us a quotient of squared, but we were the third power, so that's why we did a 3 by 2. Okay, so let's figure out what we want to do with the fourth power here. So let me erase this. So what do you think we need with the top of our fraction being a fourth power? How many do you think we need? Okay, the top is a fourth power. We're x to the fourth, we're x squared. We're actually going to use a 3 by 3. Okay, this is going to be tons of fun. Let me erase this, give us some room. So we're going to fill in what we know, x squared. Remember, if we don't have that middle term, it's a good habit to write it in. Here we have our x to the fourth, 4x cubed, three x squared, 4x, and 2. Okay, it's easiest to write in the first and the last because that doesn't take any math, any calculations. So here's a 2. Okay, we need to multiply this row and column together to get the 2. That means this top here is going to be a 2. Cool. Okay, moving on up. This piece right here are these two together. Actually, let's finish this row. That's the easiest thing to do. 2 times x squared is 2x squared. And here we have a 0x. So if we have a 0x here, we know what adds 0x plus what is 4x. We would have a 4x. Perfect. And if you look 1 times 4x. Sorry, this one right here times 1 is 4x. So here up here we're going to have a 4x. You can double check your work. 4x times 1 is 4x. So these two add together to give me 4x. All done. Now I can multiply down that column. 4x times x squared is 8x cubed. 4x times 0x is 0x. So we can add down here 2x squared plus 0x squared. Not that it matters too much. So 2x squared plus 0x squared plus what x squared equals 3x squared. That gives me an x squared. Cool. So let's figure out our unknown. 1 times what is x squared? Perfect. Now multiply down the column. X squared times x squared is x to the fourth. Check. X squared times 0x is 0x cubed. And we're done. Let's double check our work. X to the fourth. Check. 8 plus 0 is not 4x cubed. Ooh, look at that mistake. That's pretty funny. Did you guys catch that earlier and just not say anything? 4x times x squared is 4x cubed. Phew, that was a close one. So 4x cubed, 0x cubed, 4x cubed. Ha! Add this one down, 2x squared. X squared is 3x squared. 0 and 4 is 4x and 2. We did it. We have an answer with some signs in between. Here I had a fourth power and a second power. So it was easy to figure out. I needed 3 on this side because x squared, x, and 1. And to get the fourth power, I have an x squared and an x squared. So squared, singular power, constant. So 3 by 3. Let's try that again. Moving on. Test your conjectures. Use the reverse tabular method to find the quotient. Okay, you guys are going to try this one on your own. Push pause. Try to figure out what our, how many squares we need. Okay, I have a fifth power on top, a second power on the bottom. If we think about our conjecture, okay, so we have a fifth power and a second power. I'll give you a clue on this side. Oh, I'm in red. We're going to have x squared, 0x, and 4. You tell me how many you need on the top, because I'm going to have an x squared times something to give me an x to the fifth. Okay, so squared times something is going to give me an x to the fifth. I'm going to push pause. You're going to work on it. Okay, there you go. Go ahead and push pause and see if all that makes sense to you. All right, exploratory challenge continued. We're trying to find the quotient of the two problems given, and we're actually going to try to find a pattern to make life easier. So let's go ahead and figure out what our table is going to look like. If we're at x to the fifth, I do know that along here we're going to have x minus 1, and along the top we're going to need enough space for, I already know I don't have enough space. Let's erase x and negative 1. We're going to have x to the fourth on the top. So that means we need 5 columns and 2 rows. 4 columns. 4, 3, 2, 1, constant. 4, 3, 2, 1, constant. Yep. Sorry, you heard me count out loud there a few times. So it's going to be a fourth, third, second, first, fourth, third, second, first, constant, and x minus 1. I know here we're going to have an x to the fifth, 0x to the fourth, 0x to the third, that's a third, oh my, 0x to the third, 0x squared, 0x, and negative 1. So we know we always fill in our negative 1 and our x to the 5th first, and then we do some reverse math. I'm going to go pretty quick. Negative 1 times what gives me negative 1, 1, and then multiply 1 times x. Cool. To add down, if I have an x there, I need a negative x there to cancel it out, which means x times negative x. Sorry, x times negative 1 is negative x. So those would cancel out. Move here, x squared, which means negative x squared to cancel those out. X squared times negative 1 is negative x squared. X cubed, negative x cubed, which would give me x cubed, x to the 4th, negative x to the 4th, which is x to the 5th. Nope. Whoa. Look at all those mistakes. There we go. Put some pluses between here, and we be done. So that is our quotient. So what do you think our quotient is here? Can you guess? I'm going to guess that it's x to the 5th plus x to the 4th, x to the 3rd, x to the 2nd, x plus 1. Everything in between. Okay? Closing. I'm going to wrap up a few things. Okay, what strategies did we use to solve these problems? I think our first was just guessing how to make our tables, knowing that we need to work backwards across the diagonals to get all of our answers. We're using a lot of subtraction and addition and multiplication and division. And really, after you do these a few times, you'll see a pattern and you'll be able to do the work a lot faster. Tomorrow we're going to do long division with polynomials, which I actually like better than the reverse tabular method. We might do an entry ticket, but we'll see.